Hello students, welcome everyone to this lecture where I'll be revising previous year questions of chemical kinetics. Before I start with the lecture actual revision, I would like to say that many times students say that they don't have motivation to study. Okay, they always procrastinate. Sometimes parent complain that they procrastinate. They spend a lot of time on social media. Okay, the time is dissipated, the time is not used so much productively. The reason I would say is that motivation is not the thing, it is a lack of clarity. Students don't have the clarity what to study and how to study. Once you get this clarity, any student who is having the clarity that what they are doing on a given day, like you are automatically motivated to study. So let's have the clarity what to study from chemical kinetics and how to study chemical kinetic for the boards. While solving these questions of the previous year, I will be explaining the things also. Be patient and keep watching this video till end. What happens is that when it comes to the understanding, you have to be patient. You should be always having that patience of trying to understand the concepts, and then the things becomes easy. So let's start with the topic. The topic is chemical kinetics, and here we go. The first question asked is for a reaction in which H2Cl2 is given, and over here it is producing 2 moles of HCl, right? So two questions. This is for 2 marks, and there are two questions which is asked. Write the order of the reaction. Okay. So before we solve this question, what are the things a student should be knowing about the rate law? First, rate law is what? Rate law is experimental. This is something which a student should know. Rate law is experimental. Rate law is experimental. Means either you should be having the data or examiner should give you the rate law or the minimum thing that the examiner should tell that this is one step reaction, and if it is complex reaction, then the in the reaction mechanism you should have the data of which is the slower step. This is the basic idea about the rate law. So when you see over here, rate law is given this way: H2Cl2 and 2 moles of HCl. Sorry, equation is given this way: H2Cl2 and 2 moles of HCl. And what is a rate law given? Rate law given this way. Rate law given as just rate is equal to K. Means how do we write rate law? We usually write rate is equal to K, concentration of the reactant raised to its stoichiometric coefficients X. Sorry, not always stoichiometric coefficient, raised to some power which is called as order of the reaction. This is what the rate law is. This is what the rate law is. Right? Again, this is experimental. Now, there are two things. Now, what is the value of X? X will be is equal to stoichiometric coefficient. Understand? Huh? Stoichiometric coefficient. If if the reaction if the reaction is one step is taking place in one step is taking place in one step, then the reaction rate will be, or these powers will be is equal to the stoichiometric coefficients. And if if reaction is complex and takes place in more than one step, if reaction is taking place in more than one step, x is not is equal to, I'll write the order x is not is equal to stoichiometric coefficient. Stoichiometric coefficient if reaction is complex. If reaction is complex and takes place in multiple steps. Okay. Here, rate of the reaction or the power, the order in the rate law expression is equal to what? Is equal to the stoichiometric coefficient of the slowest step, right? So over here in this question, it is mentioned that rate is equal to K, let's say reactant, and this order is 0. Anything raised to 0 is what? 1, right? This is possible only if the order is 0. Rate is equal to what? Rate is equal to K. This is the rate law for a zero order reaction. So order given over here is, so write the order. So answer for the first one will be, it is zero order. State the unit of the rate constant K for the reaction. Let's derive this unit for a zero order reaction. Like basically how do we find the units of the rate constant? I'll illustrate over here. So units of rate constant, we'll write rate is equal to K, concentration of the reactant raised to 0. So K will be, like I can directly make it 1 just for your understanding. If it is, if you have to find the order other than 1, I'll write this K is equal to rate upon concentration of R raised to 0. So we are finding the unit. So we should know the what are the units of the rate. The unit of the rate is moles per liter per second. And over here, what is the unit of the concentration? Concentration is just moles per liter raised to 0. Anything raised to 0 is what? 1. So I'll just write moles per liter per second. This is small m divided by 1. So what is the unit? Moles per liter per second. So this is the answer for the second one. Is that clear? If it was like for the first order, we'll find it for the first order. So we'll write rate is equal to, okay, not a question, but if it is asked for the first order, you should know how to find concentration. Here instead of 0, I'll write 1 because it is the first order. So K will be is equal to rate upon concentration of the R. So units of rate is always moles per liter per second upon concentration is moles per liter. So you can cancel this. So moles per liter. So over here unit is per second, right? One more thing, student, units of rate constant varies with respect to, it changes with order, but units of the rate will be always same irrespective of the order. Next question here, it is asked, half-life period of a first order reaction is 693 seconds. Calculate the following. The first rate constant K is given. So for the first order reaction, um, first order reaction, the relationship between a half-life and the rate constant is given as T half is equal to 0.693 upon K. This is what the formula for the rate constant. Relationship between a T half and rate constant K. So you are told to find K over here. So therefore K will be is equal to what? K will be is equal to 0.693 upon T half. Now what is T half? What is T half? I'll just explain you in short. T half, it is a time at which concentration of reactant reduces to half of its initial concentration. This is what is the definition of the T half, right? So you are told to find a K over here. So K will be is equal to what? K will be 0.693. And what is the T half? Half-life period for the first order reaction is 693. So I am writing 693 seconds, right? So when we do this, K will be is equal to, I can write this number 0.693 as 693 into 10 raised to power minus 3 divided by 693. This and this will get cancelled, and units of the K, this second is in the denominator, it will come on the top in the numerator. So what will be the units? Units of the rate constant will be per second, right? This is the units of the rate constant of the first order reaction, and this is the value of the rate constant K. Second question, time required for the 99% completion of the reaction. Second question is time required for 99% completion of reaction. Sorry, not 99, it is 90%. It is 90% completion reaction. Now, what is the meaning of 90% completion reaction? Okay, first I'll write the formula. See, whenever you solve any numerical, there is half marks for writing correct formula, half marks for correct substitution. Now, in between, there is no marks. You can do any rough work side by side and get the answer, but half marks is for correct correct answer. Okay, this is how the whole numerical is distributed, marks distribution of the numerical correct answer. And half marks is compulsorily for writing correct units, right? This is how the 2 marks are distributed. So time required, basically the equation which we should be knowing about the time is T is equal to, over here, uh, 2.303 upon K log of R0 by R. Okay, so this is the formula. Now you should know that over here K is what? Rate constant, rate constant, and R0 is initial concentration, maximum concentration, we can say initial concentration, and R is what? This is a concentration of the reactant, concentration concentration of reactant at time t, means at this time. Okay, so whenever any reaction takes place, I'll just take you to the next slide. Let's say there is a reaction reactant A getting converted to some product B. Okay, I'll say that the initial concentration of the reactant, like at time t is equal to 0, let's say this concentration is 20, and um, obviously at time t is equal to 0, there is no any formation of the B, so this will be 0. Just try to understand the thing. Maybe after 2 minutes, what will happen is that this will become 12, and I'm just writing this side, it will become 8. Like, what we have to understand, don't worry about these values. What we have to understand is that the concentration of the reactant decreases and the concentration of the product keeps on increasing. Maybe after more 2 minutes, this will drop down to 8 and this will become 12. Maybe after more 2 minutes, what I can say is that this may become 6, means it is decreasing. And right, this is how the trend goes. The concentration of the reactant keeps on decreasing and that of product keeps on increasing. The question asked is time required for the 90% completion. See, you are not given any real values of the concentration. Okay. Now 90% completion means what? 90% completion in this case, whenever we say 90% or any percent completion means what? Completion means what? Understand that 90% completion means 90% of reactant is consumed is consumed and converted to what? It is converted to consume, and it is converted to what? Product. 90% of reactant is consumed means just 10% of reactant at that time is remaining. 10% of reactant is remaining, means this is the concentration 10% is the concentration of reactant at that time. Now, since percentages are given, many times it happens that when percentage and all these things are given, uh, student don't know how to convert. See, when percentages are given, it's very simple. Your job becomes more simpler because you have the freedom to choose any initial concentration. And for simplicity, to make our problem solving to be more simple, we consider the initial concentration to be 100. Okay, let's consider R0, R0 to be 100. Let's consider R0 to be is equal to 100 because 100 it is very easy for the calculation. So what will be the concentration of the reactant R? Now question says that 90% is complete. So it will be 100 minus 90, which is equal to 10, right? 10 amount of the reactant is remaining. If initial is 100, then R will be 10, right? And K, anyway we know T is equal to what? 2.303. K is 10 raised to minus 3 into log of R0 is what? R0 is 100, which we have taken, and since 90% is complete, so this is 10. So what will happen? This and this will get cancelled, and the answer will come to is equal to 2.303 upon 10 raised to minus 3. Log of 10, which is remaining over here, log of 10 to the base 10 is 1. So this will be 2.303 upon 10 raised to minus 3 into 1. Therefore, this time is 2.303 into 10 raised to 3. Therefore, time is equal to what? Time is equal to 2.303. Time is 2.303 into 10 raised to 3 second. You write this answer and you write this unit. You will get full marks for this. This question is very simple. Question asks is when initial concentration of the reactant is double, half-life period of the zero order reaction. Say zero order reaction, for zero order reaction, T half is given this way. T half is given as R0 by 2 times K, right? When initial concentration is double. So what you do, you just make this instead of R, like I will write this is T half 1. Okay, and now if you change the initial concentration of this to be 2 times R, it will become 2 times R0 and this is 2 times K. So if I take this 2 out, this is what? 2 times R0 by 2K. So can I write this 2 and what about this term? This term R0 by 2K becomes is equal to what? T half 1. So new T half 2 will be 2 times of the T half 1. So it is 2 times, so answer is what? Doubled. So next question over here is derive integrated rate equation for zero order reaction. Next it is continued. The 3/4 of first order reaction is complete in 30 minutes. Calculate the half-life period. So first we'll understand the derivation of this. Okay, we'll understand how to derive this. So consider, I'll write, we'll start with this. Consider reaction reaction reactant R changing to product P. Okay, we'll write it this way. So how do we write rate? Rate is equal to, we'll write rate is equal to K R raised to, since it is 0, I'll write it this way, right? So how do we define the rate? Like differential rate equation, we write this to be minus dr, that is initial concentration or a concentration of reactant at time t, is equal to, I'll just write this is equal to K and anything raised to 0 is 1, right? So what do I write is minus dr is equal to K and this dt I am taking over here. So therefore dr is equal to, dr is a small change in a concentration of the reactant at in small time dt. So this minus sign I'm taking on the other side. So this is my equation 1. This is my equation 1. Integrating equation 1. If I integrate this, integrating equation 1 means I'll write this. Integral of dr is equal to minus or integral of minus k dt. Integral of dr, I'll write this one more time. And over here, I'll take my k is a constant. Integral doesn't work on constant. So I'll just write dt. So therefore, integral of dr becomes r and minus k as it is, and the integral of dt becomes t plus c. C is what? C is a integration constant. C is integration constant. Integration constant. Now this is one equation which I am getting over here. This is one of the equation which I am getting. But this is not the final equation. I need to find what is C. Integration constant, that is what I need to find. So I'll write over here. I'll write over here that or I'll go to the next page. At time t is equal to 0, we'll assume at time t is equal to 0, at time t is equal to 0, what is R? The R becomes what? The concentration of the reactants will be is equal to R0, means R is initial concentration. R0 is initial concentration. So therefore, substituting above things, substituting t is equal to 0 and R is equal to R0. In what? In equation 1. So this all everything is to find C, which is integration constant. So if I do this, what was my equation 1? Equation 1 was saying that equation 1 was this, R is equal to minus KT plus C. So R becomes what? R0 in equation 1 is equal to minus K, time is equal to 0. So this is 0 plus C. Therefore, C is equal to what? C is equal to R0. Now substitute C is equal to R0 in equation 1, right? What do we get? We get R is equal to minus KT plus R0. So what I'll do is over here, this is the equation which was expected from you when it comes to the integrated rate law expression for the zero order reaction. This is the equation, and for this there is a marks, deriving this and whole derivation there is a marks. Now the question is, like I'll tell you some extra things about this. This is the equation and you should know the graph also regarding this. So this is the equation. R is what? Variable, and this is minus KT plus R0. So if I want to write this on a graph, I'll write it this way. If I want to represent this on a graph, I will represent it this way. So this is on a y-axis, this the time, this is the y-intercept, that is R0. Okay, sorry, not this way. R0 this way. So this is intercept, which is equal to R0, maximum value of the R0, right? This is that intercept, right? And this is a slope of this is negative, which is minus K. Now you can easily understand this if you know the equation of a straight line. Equation of a straight line. Equation of a straight line is what? Equation of straight line is y is equal to mx plus c. So over here, if you see, both y is a y variable, x is a x variable. Means this is my y, this is my x, and m is what? M is slope. But over here, and minus k means negative slope. If it is a positive, then it would have graph would have gone this way, right? So this is one of the equation, and c is what? C is the y-intercept. C is the y-intercept over here. So over here, if you see, this is cutting on the y-axis. So this is the C, which is R0. So if you want to understand, this is y, this is minus mx, and this is C, right? This is how we can understand. So this was not asked, only till here the equation was asked for the integrated rate law expression. Now next thing which is we have to understand is 3/4 of the first order reaction. 3/4 of the first order reaction is complete in 30 minutes. Calculate the half-life period of the reaction. Like this is the question. So we'll go ahead. So T half for the first order reaction. Now question is about the first order. T half for the first order reaction is 0.693 upon K. And for this we need a K. So to find K, We'll write K is equal to 2.303 by T log of R0 by R. Now what they have said is that 3/4 of the first order reaction is complete. Understand this. 3/4 of the first order reaction is complete. Means how much is remaining? If 3/4 is complete, then 1/4 is remaining. Right? Means R will be what? So I'll write over here R0 is what? Let's say R0 is, let's take 100 only. I can take 1 also, no issue. We'll take 100. We'll take 100. Okay. And 3/4 of this reaction is complete. Means R will be is equal to what? What will be this R? R will be is equal to 100 minus 3/4 into 100. When we say 3/4 is complete, 3/4 of the first order reaction is complete, means we are subtracting from the 3/4 of the 100, or sometimes they give the percentage 20% is complete, so we subtract it that way. So if you solve this, then what would be this? This will be 1/4 of the 100. If you solve this, okay, I'll solve this for you. What will be R over here? You'll understand it. There are different ways you can solve. So here this is nothing is there means 1. So I'll write 1 into 4. This is 4 into 100. This is how you do. 4 into 100 minus 3 into 100. As a science student, it is expected that you should know all these things. Since I am making this video, I am doing all these detailings. So this will be what? 4 minus 3. I am taking 100 common over here. And this is 4. So this is 1 by 4 into 100. This is what our R is, right? Therefore, K is equal to 2.303 upon time is how much? 30 minutes, I guess. Yeah, 30 minutes. And don't, there is no need to convert this. We'll write the rate of the unit of the rate constant per minute. So log of R is what? R is 100 and this is 1/4 of 100. So what will happen over here? I can cancel this 100 and 100 nicely. So what remains over here is K is equal to 2.303 upon 30 into log of 1 by 1 upon 1 by 4. So this will be log of 4. Now how to find log of 4? Everyone should know that log of 2 is very important. It is 0.3010. Everyone should know this log. So how to solve this part? I'll write over here. Therefore, K is equal to 2.303 divided by 30 log of 4 could be also written as 2 raised to 2, right? It could be also written this way. So from the identities of the logarithm, can I write this as 2 into log 2? There is an identity. Log of a raised to x could be also written as x log of a, right? So based on that identity, I am writing this. So therefore, this will be is equal to what? 2.303 divided by 30 into 2 into 0.3010. And final answer, when you solve this, it comes to is equal to, we are finding K. The question is not over. We are finding K. K I am getting over here to be is equal to 0.046. This is what the K value is. And therefore, you are told to find a T half. Therefore, substituting it in the formula of the T half, which is equal to 0.693 upon K is what? 0.046. 0.046 unit of this is per minute. Therefore, T half, when you solve this answer comes to 15.06 minute, because numerator denominator it goes to numerator. So this is the answer. Like total marks for this question was 4 marks. 2 marks for the derivation and 2 marks for the problem. This question asked is what is the differential rate equation? Total 4 marks, 1 for writing the differential rate equation, then 1 mark for what is the effect of adding catalyst on the activation energy, and then 2 marks is for calculate the activation energy of the reaction and the rate doubles, all these things. So how do we write a differential rate equation? Differential rate equation for this is a reactant. So we always write minus when, since the reaction in the reaction the reactant gets consumed, we write d H2 by dt, which is equal to which is equal to minus d I2 or d by dt of I2, and over here stoichiometric coefficient is 2, so 1 by 2 d hi by dt. So stoichiometric coefficients whichever are there we divide it by those terms. So this is what a differential rate equation for this. Now what is the effect of the catalyst and how you are writing it for the exam? So what we can write, what we should be writing for the exam, what is the effect of the catalyst of adding catalyst on the activation energy? Basically what catalyst do you should be writing nicely. Catalyst, make a note of this also. Catalyst lowers the activation energy, the activation energy, lowers the activation energy between reactant and product, between reactant and product. Make a note of this. If you write this systematically you get the marks, and hence reduces potential energy barrier. This is how you should be writing, because this is what is clearly mentioned in the NCERT. Okay, how clearly it is mentioned in NCERT. So next question is asked, means a continuation of the same question is calculate the activation energy if the rate of the chemical reaction doubles for increase in a temperature from 298 Kelvin to 308 Kelvin. Directly the Kelvin thing is given, directly it is given in Kelvin. So we'll write the formula first. For this, there is a equation which tells about the dependency of the rate constant on temperature. Means rate constant is going to vary with increase in temperature. If you increase the temperature, rate constant is going to vary. Otherwise, rate constant don't vary for a constant temperature, right? So like that is Arrhenius equation which tells that, but there is equation one more derived from the Arrhenius equation, that is this. You are expected to write this equation. Writing a formula for the exam is very important. Log of K2 by K1 is equal to EA upon 2.303 R 1 upon T1 minus 1 upon T2. Okay, so I'll just write over here what is K2. K2 is rate constant at higher temperature. Rate constant at higher temperature. At higher temperature. What is K1? K1 is rate constant. Rate constant at lower temperature. Lower temperature. What is EA? EA is activation energy. EA is activation energy, and this is what you are told to find, right? EA is activation energy. R is gas constant. Given value is um, sometimes they don't give, but you have to remember this value 8.314 joules per Kelvin per mole. Now, what is T1? T1 is lower temperature. Lower temperature. And T2 is what? T2 is higher temperature. Okay, this is the formula. But many times students say, there is a difficulty. That difficulty is very simple. Sometimes they write 1 by T2 minus 1 by T1. Sometimes they put higher temperature over here, lower over here. See, understand one thing. If you put a lower temperature, higher temperature over here, what will happen? That whole term will become negative. We don't want negative terms. Always understand that this is T1 is lower temperature over here. You have to write it this way. Okay. We'll put the terms. Now, in the question, it is mentioned, it is said that calculate the activation energy if the rate constant of the chemical reaction doubles for an increase in a temperature from so and so. Rate constant doubles means my K2 is becoming 2 times of the first one. Let's say K1 is K1 is X, then this will become 2 times X. This is what I am saying. So therefore, how do I solve? I write it this way. Log of 2x upon x is equal to EA is the thing you need to find 2.303 into R is 8.314 upon 1 upon T1 is lower temperature, that is 298 Kelvin minus 1 upon 308 Kelvin. There is a difference of 10 units over here. So you see over here, this x and this x will get cancelled. What remains is log of 2 EA upon 2.303 into 8.314, and I'll write it this way. 298 multiplied by 308 and then 308 minus 298. Okay. So this becomes log of 2 is 0.3010. Everyone should know this. Don't search for a log table for finding log of 2. It will simply consume your time. EA is equal to 2.303 into 8.314 into this difference is of 10 upon 298 into 308. So EA unit I'll tell you later. This is 0.3010 to 2.303 into 8.314 into 298 to 308. Basically, such a long calculation, multiplication, you should handle it by using log. That is quicker. Find a log of this, log of this, log of this, log of this, and log of this, and then add the log, and then find the ND log. That will be the answer. Okay. Uh, Over here, EA comes to be equal to, finally after solving this part, EA comes to be is equal to uh, 5289.7 joules per mole. Now you will be thinking how to remember these units, joules per mole. I can write this further as 52.89 rounding of kilojoules per mole. How to find the units of this? See, to find the units of this, we'll find the units of this EA. How we are getting that unit? Okay, how we are getting the units of this. Like this is for your illustration, your understanding. So we are finding the units of A. So units of 0.3010, it doesn't have any unit. This also doesn't have a unit. Unit is having 8.314 has a unit of joules per Kelvin per mole. The unit of this is Kelvin. Again, this is Kelvin divided by Kelvin. So this Kelvin, Kelvin and per Kelvin. What remains is joules per mole. This is a unit which I have written over here in this question. It's the unit, joules per mole. Very important. This question, for this question, there is a rate they have given. Over here, like just an extra thing for you to understand. Over here, if you see the stoichiometric coefficient of this is 1 and this is 2, and that is same is equal to its order, you see. Means what is a conclusion about this? The conclusion about this is that it is a one step reaction. It is not a complex reaction, it is a one step reaction because stoichiometric coefficients are equal to power over here in a rate law expression. Okay, apart from this, you don't require this information to solve this question. This was just extra added thing I told you since I found that equation over here, reaction and the rate law expression. So if the concentration of B is double, then the rate of reaction will be. So we'll write the rate constant, the first rate constant given over here is, I'll write this as rate 1, where it is given this way, K, A raised to 1 and B raised to 2. This is what is given. Now if the concentration of B is double, what will happen to the rate? We'll write new rate, that is rate 2. Obviously rate will be changed and that will be different from the rate 1. Why? I am changing the concentration of the B and it is equal to 2 times. We have doubled that concentration. Earlier it was B, now I made it 2. So this is what K, A raised to power 2, power 1, and this 2 will become what? 2 square, and I write this B square. So this is 2 square is what? 4. I'll write it separately. K A1, A1 means A raised to power 1, first order I mean, and this is B raised to 2. So what is this K A1 B raised to 2? So this is rate 1 if you see this and this equation. So therefore rate 2 is what? 4 times of the rate 1. So what is the answer? Increases by 4 times. Increases by 4 times. Again, these questions are from, I guess, yeah, it is from paper of the 2022, where all the questions were MCQ. Still, a very good question to solve. A Foster reaction is half completed in 3 minutes. How long does it take for the completion of the 99% of the completion of the reaction, right? So first reaction has a half life. Like how to find the thing they have asked is a time. So time is equal to for the first order reaction is 2.303 by K into log of R0 by R, right? But over here R0, since they have given the percentage, we can easily find the R. Since they have given the percentage, you can easily find the R0 and R, but we need to find K. But they have given a half-life. Half-life is completed. See this, that was an exceptional case where it was asked for 1 marks. This question should be coming for the 2 marks. Okay. If it is MCQ, then it will be surely coming for the 1 marks. But there is so much work in this that 2 marks are deserved for this. Okay, this question deserves 2 marks. So 2.303 by K into log of R0 by R, we need to find K. The first order reaction has half-life of 3 minutes. So for this, T half is equal to what? 3 minutes. From this data, we can easily find what is K, right? So K is equal to what? Or we know that T half, T half is equal to 0.693 upon K. Therefore, K is equal to 0.693 upon T half. What I do is I keep this, I'll write this K as 0.693 upon how much it is 3 minutes, right? 3 minutes. So this is my K, 3 minutes, right? So K will be what? 0.693. Like you can cancel this. 3 0.231, right? So this will be 0.231 per minute. This is my K. Now question says that 99% completion. So can you comment what will be the percent remaining one? Like what will be the value of R? So if R0, I am saying that R0 is 100. I am assuming that it is 100. So what will be R? R will be 100 minus 99 because 99% is complete. So just 1% is remaining, right? So over here, therefore, time is equal to 2.303 by K. Sorry, K is what? K is 0.231 multiplied by log of R0 is 100 divided by 1. Means it is what? Log of 100 is 2. 2.303 upon 0.31 into log of 100 is 2. So when you solve this, uh, like for this, if you can do partly some approximation, you really don't need to solve this using, traditional. Can I write this 0.231 as 2.31 into 10 raised to minus 1 and over here into 2? Like this is, you can cancel them approximately. So answer becomes 2 into 10 raised to 1, which is equal to how much? This comes to is equal to 20 units of K over per minute. So now it is minute. Answer is 20 minutes for this. If the rate constant of the reaction is 0.3 into 10 raised to minus 4 per mole liter per second, the order of the reaction. So over here, the question is asked for the order of the reaction. They have given some value and also the unit. Now, it's obvious we can find the order of the rate constant by looking at the units of the rate constant. We know that for a first order reaction or for a zero order reaction, if you solve zero order reaction, units of K comes to be is equal to um, moles per liter per second. For order reaction, units of K are just per second. And this is a second order reaction. Okay, second order reaction, K will be, units of K will be per mole, liter per second. Let's prove this, how this is correct, right? So we'll find the units of the second order reaction. That is, we'll write rate is equal to K into concentration of reactant raised to 2 because it is second order. So I have written it 2. So rate is what? Moles per liter per second. K units of R are what? Means concentration is moles per liter raised to 2. So K is equal to what? Moles per liter per second, and down it is moles per liter raised to 2. So you open this bracket, this becomes mole square liter raised to power minus 2. So when you take that in the numerator, mole raised to 1, and this is what? Mole raised to minus 2. This becomes mole raised to minus 2. This is liter raised to minus 1, this liter raised to 2, and this per second is there. So 1 and minus 2, base is same, so minus 1 plus 2, this is liter per second. Per mole, liter per second is the unit of the second order for units of the rate constant for the second order reaction. So answer is option C. So this question over here. So which of these options are correct over here? That is what is asked. So options, which of these options will be correct? So if you want to write a differential rate equation for this, like these are the reactants and these are the products. So how do we write? Simple. The stoichiometric coefficients are there. We'll write it in the denominator. And negative for the reactant minus, this will become 1 by 3 d change in concentration of NO2 by dt, which is equal to minus dt, which is equal to positive for the product. So match the answer. Answer is not this one. Minus 1 by 3 dNO2 minus 1 by 2. So the answer is option C for this. Very simple question. Don't lose marks for this type of questions. Now this question over here, again MCQ, the statement that is true about this reaction. The reaction is of the second order, no. Over here, if you see the rate law equation, the order will be what? This is 1, nothing is there means 1 plus 2, oh sorry, not 1 plus 2, 1 plus 1 by 2. So this order over here comes to be is equal to what? 2, 3 by 2, right? So this is not the correct one. This is not the answer. The order of the reaction is 3 by 2. Yes, this is the correct one. Option B is the correct one for this. The units of K is per second. If the order is 3 by 2 units of the K, you know that this unit is only for a first order reaction. Okay, the molecular rate of the reaction is 3 by 2. Molecular rate of the reaction cannot be fraction. We know this. It is always a whole number. Molecular rate of the reaction cannot be a fraction. 3 by 2 is a fraction. So the answer is option B over here. Write only mathematical expression used to calculate the activation energy. Then it's very simple. This is what the equation you need to write. Now only equation they have asked means here you need to define the terms also. Log of K2. How will be writing log of K2 by K1 is equal to EA upon 2.303 R 1 upon T1 minus 1 upon T2. Now simply don't write the equation if this is the question. Also you need to define the thing like what is K2, what is K1, right? So be writing K2 is rate constant at higher temperature, rate constant, or I'll just copy it from the previous slide. I am having that. I simply write again and again from here. Like this is what exactly you need to write. because only like for if numerical, for this numerical you don't have to define everything. Even if you just write the formula, that is fine. But when just formula is asked, when a formula is asked, you should be defining everything. Like this is what should be the answer whole for a 1 mark. It looks very systematic. Teacher, examiner understand that you know the things and you see the intent over here. Reaction. Okay, starting from the integrated second part, starting from the integrated rate law equation of a first order reaction, derive the expression of its half life. Now, starting from the integrated rate law. So, what is that equation? Integrated rate law equation. The rate it is equal to log of R0. It starts with this way, no? Log of integrated rate law equation. Log of R0 is equal to minus KT plus log of, sorry, not R0. This is log of R and this is log of R0. Again, this is like a equation of a straight line. Let's discuss it after this. Not required for this question, but you should know. What is asked is half-life. So I'll just rearrange this in terms of time. So this minus KT term I'm taking this side and I'm taking this, I'll write this log of R0 minus log of R. So Kt is equal to what is this? Log of A minus log of B could be also written as log of A upon B. So over here this becomes log of R0 by R, right? Therefore time is equal to, sorry, I think I made a mistake in writing this. Here it is 2.303. Here also it is uh, where I was. Yeah, here this will come to 2.303 because the equation actually starts this way. Actually, equation starts this way. I'll write the equation. Okay, I'll do everything from the start. From where to start? For the clarity, the equation is this way. ln of R0, sorry, ln of R is equal to minus KT plus ln of R0. When you convert natural logarithm log, you multiply it by 2.303. 2.303 log of R, or we'll rearrange this first, then we'll include this. So I'll write this KT is equal to ln of R0 minus ln of R. So KT is equal to what? KT is equal to ln of R0 by R, right? So when you convert natural logarithm to log, it becomes 2.303 log of R0 by R. Okay. So time is equal to, I'll write 2.303 upon K log of R0 by R. You can start from this equation also, not an issue. So T half for a half life. So I'll write T half is a time at which concentration of the reactant is reduced to half of its initial concentration. So at T half, what we'll write is at T half, R will be is equal to what? R0 by 2. This is what we are writing. Very simple. So therefore, T I'll write label as a half 2.303 upon K log of R0, and this is what? R0 by 2. So what will happen? R0 will get cancelled and over here this will be 2.303 upon k, and this will become log of 2. What is like this denominator to numerator, right? So this is in the denominator is 1 by 2, it will become 2 over here. So what is log of 2? Log of 2 is 0.3010 upon k. This is t half, and this finally comes down to t half is equal to 0.693 upon k. So this is the thing. Now, more thing I would like to talk on this equation is that see, equation is this way: ln of r is equal to minus kt plus ln of r0. See, if you relate this to equation of straight line, this is y, this is mx, and this is c. Means x is a variable which is a time variable. So if you plot this graph, the graph should be this way. Graph should be this way. That is, on this axis ln of r, this is time, and this is the intercept. Here it is the intercept, that is ln of r0, and over here the slope is minus k. But if the equation is in terms of log, then how the graph will be and what will be the slope? Over here the slope is equal to what? Slope is equal to, over here the slope is equal to minus k. This is what the slope, negative slope it is. Now, if the equation is in terms of log and not in the natural logarithm, then what will be the slope? Okay, we'll try understanding that. Okay, we'll slightly modify this equation first. Ln of r is equal to minus kt plus ln of r0. So when we convert natural logarithm to log, I'll write this is 2.303 log of r is equal to minus kt plus 2.303 natural logarithm to log. So log of r0. Now I want to get rid of this 2.303, so I'll divide the whole equation by 2.303. So this. So over here, the new equation in terms of log becomes minus kt upon 2.303 plus log of r0. Now, what will be the graph? Graph will be similar. Graph will be similar, but only thing is that slope will vary. Like slope will be different. Slope will be different. So this is, instead of log ln, you are writing log of r0. This is, sorry, this is r, not r0. This is log, this is time, and this is the intercept. This is the intercept whose value is log of r0, maximum value of the concentration. And over here, the slope is constant. What is the constant? This part is constant, minus k by 2.300. Slope is minus k by 2.303. So all these things you should be knowing about the first order equation. Okay, this question is straight from the NCRT. If you're reading the NCRT, you'll be able to do this nicely. Write the differential rate equation. This is conceptual. How do we write? Minus D, concentration of sucrose, that is C12 H22 O11 by dt. I'm writing the answer for the first one is equal to um, Over here, concentration of the water we are taking constant, so we don't have to consider the concentration of the water. It looks like a second order reaction, but it is called as a pseudo first order reaction, which is given in NCERT. So this will be, I'm not considering, I'm writing this product wala. So this is C6H12O6 by dt is equal to D C6H12O6 by dt. Now we'll be saying that both will be same. Like understand they are the isomers. One is aldehyde isomer. We are learning this in biomolecule also. That they both are isomers of one another, though they have the same molecular formula. This is the differential rate equation. What is the rate law equation? Rate law equation will be, this is a pseudo order reaction which looks like a second order reaction, but it is a first order reaction which depends only on the concentration of the C12H22O11. So this is rate is equal to what? K concentration of C12H22O11 raised to 1. What is the molecularity? Only over here two molecules are involved. One is of the sucrose and the other is of water. Therefore, molecularity is what? Molecularity is 2. Okay. And the order of the reaction is 1 because this looks like a first order reaction, but concentration of the one of the reactant, that water, remains fairly constant throughout the reaction in this hydrolysis. So this is, you will be calling the order of reaction. Writing this term is very important. Pseudo first order reaction. That's it. Here there is one more question which is similar to the previous questions we have solved. A first order reaction is 20% complete in 10 minutes. Calculate the time required for the 75% completion reaction. I'll do this very quickly. Time required, time formula is this. Time is equal to, for the first order reaction, T by 2.303 K log of R0 by R, right? And what they have asked, if calculated time required for the 75% completion, means when this is given, I can consider the initial concentration to be 100 and the concentration left to be 100 minus 75, right? But we need a K, right, to find K, right, to find K. So because K is going to remain constant, because this reaction temperature is not changing. If temperature is changing, then the K will change. So to find K, I use the same formula. To find K, I use the same formula, but I'll write K is equal to 2.303 upon T log of R0 by R. Now over here, what is the time? The first order reaction is 20% complete in 10 minutes. Means time is equal to 10 minutes. 20% complete, so I'll consider initial to be 100 and R concentration at time after 10 minutes will be 100 minus 20 is complete. So how much is remaining? 80. See, many times, sometime the question may be like the concentration of reactant reduced to 20%. Reduced to 20% means you don't have to subtract, you have to consider the concentration to be that 20% of the reactant. So understand this difference, reduced to 20% and the reaction is complete 20%, right? So I'll go on the next page. So therefore, K is equal to what? 2.303. Time is 20 minutes, sorry, 10 minutes. So I'll write that time is equal to 10 minutes. Log of R0 is 100 and 20% complete. Over here, this is 80, right? 20% complete. So this is 80. So this and this will get cancelled. Now the thing is that The great challenge is finding log of 10 by 8, right? So I'll solve this separately. Log of 10 by 8. I can write this as log of 10 minus log of 8. So log of 10 is 1, and I'll write this, since I know the log of 2, I'll write this log of 8 as 2 raised to 3. So what this will be 1 minus 3 log 2. So 1 minus 3 into log 2, 1 minus 3 into 0.3010, right? So this is 1 minus 0.9030. So this answer comes to 0.097. 0.097. So only this part I have solved, only this part. So I'll write k is equal to 2.303 by 10 into 0.097. Okay, 0.097. 0.097 is very close. If I can approximate this 2.303 upon 10, can I write this as 0.1? It is very close to, I'm rounding it off. So this is 2.303 into 0.1, and this becomes 10 raised to minus 1. And what is this? 0.1 could be also written as 10 raised to minus 1. So this is k is equal to what? 2.303 into 10 raised to minus 2. This is our k value. Now I need to find for a 25% completion reaction. Sorry, 75% completion reaction. Now k we got. So time is equal to 2.303, and k I am getting 2.303. Uh, it was into 10 raised to minus 3 per minute into log of R0. I'm considering 100. 75% completion means I'm considering R0 to be 100, and 75% completion means 100 minus 75, which is equal to 25. So divide by 25 over here. So this is time is equal to 2.303. Okay, this and this will get cancelled. I'll just write 1 by 10 raised to minus 3 into 25 fours are. So log of 4. Now log of 4 is very easy. Log of 4 could be also written as log of 2 raised to 2. So this is 2 into log 2. So 2 into log 2 is what? 3, 0.3010, which is equal to 0.6020. So 0.6020, and this 10 raised to minus 3 will become 10 raised to 3. So time will be 602 minutes. One minute, I think, yeah, it is 10 raised to minus 2. I just made a mistake, sorry. This is 10 raised to minus 2. Here also minus 2. And this will become 10 raised to 2. And this will become 60.2 minutes. So answer is this. Okay, this question is slightly different. It looks slightly different, but if you go to the final conclusion of this question is very simple. A piece of wood shows C6 activity, carbon's activity, which is 20% of the activity found today, right? This is what is the question is. This is what it is saying. Hmm? Uh, so here What is the meaning of this? And what they have said is that calculate the age of the wood sample. They have given T half to be 5770 these many years, right? And if the decay follow first order, calculate the age of the wood. Age of the wood means I am finding total time, right? Means to find a time, what I require again this equation 2.303 by K log of R0 by R. But I need a K also. So what is K for a first order reaction? 0.693 upon T half. T half is given to be what? 5770, right? So here what I write is 20% of the activity. 20% activity means this is the actual concentration of the reactant will consider. Activity is found today means that is what the concentration of this carbon. This is the question about the carbon dating. So we'll write the time is equal to 2.303. K is what? 0.693 upon 5770. 0.693 divided by 5770. I'll write this 5770 over here. And log of this will be 100 divided by R. I am writing 20. And now you should solve from here. It's very simple. Now log of 5 is difficult, but you know log of 10 and log of 2, right? If this is there, don't cancel them. You can write this log of 10 minus log of 2. Log of 10 is 1 and log of 2 is 0.3010, which comes approximately is equal to zero point 0.7, right? And you solve this further. I'll write the answers directly. This answer directly comes to 13422.53 years. Okay, when you solve this. Uh, Again, this derivation is for 2 marks. Derive the integrated rate equation for the first order reaction. Now, this is for the first order reaction. Let's derive. Consider while writing how you should be. You should be as much as presentable as possible. So we'll write consider reaction reactant R changing to product P. So over here, rate will be is equal to what? K R raised to 1. So what would be this? Rate is what? I can write minus dr by dt, change in concentration of R, is equal to K R. So I'll split this term, I rearrange these terms. So I'll write this minus dr is equal to Kr dt. So dr is equal to minus K R dt. Um, what I'll do is, sorry, not this way. I'll write this way. Take this R down and this K other side as it is, and dt. D R minus K dt. Okay. So this is the equation 1. This is equation 1. Just a second now. This is the equation 1. So integrating equation 1, integrating equation 1, I'll integrate this. So I'll write this term as dr by r is equal to integral of minus k dt. So this term could be also written this way: 1 by r, where dr is an operator, minus k will come out, and I'll write integral of dt. So integral of 1 by x is what? ln of x, right? So ln of r I'll write, because this is 1 by r dr. So ln of x dx is 1 by x dx is ln of x. Over here 1 by r will be ln of r. This side it is minus kt plus c. So to find c, we'll consider at time t is equal to 0, r will be what? R will be is equal to r0. Therefore, ln of r0, I am substituting this, will be minus k into 0 plus c. Therefore, c is equal to what? ln of r0. So substituting ln of r0 in equation 1, what do you get? Like, what was the equation? This is equation 1, right? This will be ln of r, which is equal to minus kt plus ln of r0. And this is your integrated rate law expression. And this resembles to the equation of a straight line: y is equal to mx minus mx plus c. Okay, with a negative slope. And the other things regarding the graph I have already discussed in the previous question. So this is the thing which is expected from you too when it comes to derivation. Very important. Do both the derivations, zero and first order. This question is again based on activation energy, where I feel that you need to find the activation energy. So I'll write the formula, that is log of K2 by K1, which is equal to EA upon 2.303 R 1 upon T1 minus 1 upon T2. So over here, like, temperatures are given in, like, T1 is 30 degrees Celsius, which is equal to 273 plus 30, means it is 303 Kelvin. And the other is T2 is what? T2 is 40 degrees Celsius, which is equal to 273 plus 40, which is equal to 313 313 Kelvin, right? 313 Kelvin. K2 is also given directly, they have given, they did not say 3 times, 4 times, something like that. So you see there are two values: rate constant 1.2 into 10 raised to minus 3, and other is 1.4 into 10 raised to minus 3. So this is lower rate constant, this is higher rate constant. Okay, they have mentioned respectively. So my K1 is 1.2 into 10 raised to minus 3 per second, and K2 is 2.4 into 10 raised to minus 3 per second, right? So what I do is I'll write this way: substitute log of K2 is what? 2.4 into 10 raised to minus 3, and this is 1.2 into 10 raised to minus 3. EA we need to find, this is 2.303, R is 8.314, and the temperature is 1 by T1 is 303, and T2 is 313 Kelvin. So 1 by 2, this and this is log of 2 EA upon 2.303 and 8.314, like simple calculations. 313 minus 303 divided by 303 multiplied by 313. So log of this will be 0.3010, This difference is 10, 303 and 313. So EA will be is equal to 3010. So this answer comes to be is equal to 546,584 joules per mole. In kilojoules per mole, it is 54.658 kilojoules per mole. So, in this session, I have covered all the questions of the previous years. Hope this will help you out for your upcoming board exam. It may be a prelim or your final board exam. Okay, if this video has helped you in understanding the concepts of the chemical kinetics and have developed some confidence in the subject in this topic, please like, share, and subscribe. Thank you.